What about a one-tailed or a directional test? These tests only have one rejection zone. All right, it's like putting all your eggs in one basket. Instead of taking your rejection zone and splitting it in two, if we want, we can put all the area, the rejection zone area, into one tail. All right, make that area larger. And if we can make that area, the rejection zone, larger, we have a better chance of falling into the rejection zone. All right, but in order to use this one-tailed test, which sounds awesome, right? Have a bigger target to hit, right? Double your size of the rejection zone means that it's like having a bullseye on the dartboard that is at least twice the size, right? It's twice the size. It's easier to hit it. But in order to do a directional test, it means that you have to phrase your hypothesis in such a way that it's directional, and you have to have literature to back that hypothesis up. All right, published literature needs to support your directional hypothesis. And I'm going to, show that, about that some more in a minute. Okay. Now, so if you're predicting that the yellow room is going to give you higher scores than the blue room, if that's your prediction, then, well, we're expecting this tail, but only if yellow was group 1. All right. If yellow was group 2, we would have predicted this tail. But more important than, is your TS positive or negative? Have you correctly identified the tail that you're going to be in? All you really have to know is are the means in the same direction as what I predicted? So if you're predicting yellow is going to be greater than blue, and you run your experiment, and in fact, X bar for yellow is bigger than the X bar for blue, then you know that you're in the correct tail. It doesn't matter if you specify the tail on this side or that side, you know you must be in the right place because your X bars are consistent with what you predicted. Okay, so don't get too hung up. Am I in the right tail? Again, are your X bars in the same direction as what you predicted them? All right, so if that's the case, then your TS is here, and you can reject HO, and you can say your results are significant, etc., etc. However, if your TS is not in this rejection zone, that means your TS must be somewhere here, right? And here's the thing. It could be way out here, but it's in the wrong tail, right? The means are opposite to what you predicted. And you could be way, way, way out here. And you're like, man, that's got to be significant. Well, it's not, because you only defined one tail. All right. So you might think, okay, great, I'm screwed. Not necessarily. And that's because we can just go back to our original hypothesis and remember that magic key on your keyboard, the delete key. We'll just go delete, 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 and change this and flip your hypothesis. So instead of saying yellow is going to be higher than blue, say yellow will be less than blue. All right, now you might be thinking that's cheating. No, it's not. The rules say for you to have a directional test, for you to use a one-tailed test, you have to have a hypothesis that is directional, and you have to have literature, published literature, to support your prediction. So if your original prediction was this, and you had the literature to support it, great, you met the rules. If you get results that are opposite to what you predicted, Well, the rules say you just have to make a prediction, right? So changing this does not violate a rule. Just change the direction of the prediction. And what's the second part of the rule? You have to have literature now to support that new prediction. All right, so as long as you can go back and find literature to support your new prediction, you can flip your hypothesis, and now you will be in this tail. Do you see how awesome that is? You just have to flip your hypothesis. So I'm not sure if I gave this example in the book, but if I did, then I'm refreshing your memory. And if I didn't, it's a good example. Let's just say that I want to test whether alcohol is going to decrease test scores. So what I do is I have two groups. I have one group that's given a drink that smells like, looks like, tastes like alcohol, but it really isn't. And we'll call that the placebo group. And then the other group gets the real thing, a shot of real whiskey just before going into the testing center, right? So the placebo group gets a shot of placebo, and the treatment group, well, they get the shot of whiskey. Now, I'm expecting that the group that got the shot of whiskey is going to do worse on the exam. All right, so whiskey will be worse than placebo. Do I care which tail I'm in? Well, I am going to have to shade in one side, but which side I shade in doesn't really matter because it depends on, just like here, do I go placebo minus whiskey or whiskey minus placebo? All I really care about is that after I do my study, I look at my X bars. All right. And if in fact the mean for whiskey was lower than the mean for placebo, then I know I'm in the right tail because my X bars are consistent with my prediction. But let's say that lo and behold, the whiskey group actually does better. All right. Then I'm like, uh-oh, I'm in the wrong tail now, right? Because I predicted the opposite. So I'm going to have to flip my hypothesis. If I don't, I'm going to have to say my results are not significant. Okay, well, with my first prediction, whiskey will do worse than placebo. Do you think I can find literature on that? That literature saying that alcohol impairs cognition? Absolutely. I'm going to be able to find those studies. But if I flip it, am I going to now be able to find new literature that says alcohol will improve cognition? Well, what do you think? Can I find those studies? Yes, I can. Because guess what alcohol does? Alcohol lowers anxiety. So if I've got a bunch of stressed out students about to take an exam and I give them the whiskey, well, the placebo group, in theory, you wouldn't expect them to change too much either way. But the group that got whiskey, if that lowers their anxiety levels, they may very well do better on the test. And so I have flipped the direction of my hypothesis and supported it with the literature. I've now satisfied the criteria for that for that one directional test. And I can go ahead and run it. All right. And again, as long as my means are in the same direction as my prediction, I know I'm in the right tail. Okay, and I haven't violated any laws. And just as an FYI, I am not suggesting in any way, shape, or form that you do take a shot of whiskey before your next exam. Just covering my you-know-what. Okay. Now, this is just reiterating what we saw on the previous slide. We said if you predicted that yellow was going to be greater than blue, but in reality, you got X bars that said yellow is actually less than blue, then you just flip your hypothesis, change that direction sign. So this is your hypothesis, and find literature to support it. Okay. Similarly, if you were predicting this and you got results in your samples that were opposite, so yellow was in fact greater than blue, then you flip this here and you move it over here. All right, just you have to have literature to support the new hypothesis. That's all it takes. All right, just flip it.